So today we are going to discuss about the how design thinking will apply in the next generation semiconductor devices. So this is the our design thinking video topic here. Okay, so we know about semiconductor, right? So the audience will be the semiconductor physics. Okay, so what is the semiconductor? So it acts as both conductor as well as insulator, right? So it is the material, the resistivity and conductivity is lies in between conductor as well as insulator, right? Okay, so it has certain band gap. Okay, so it has certain many properties. Okay, so the resistivity and the conductivity is lies in between conductor and the insulator. Okay, this is semiconductor material, right? Okay, so it acts as both conductor as well as insulator. So when it behaves as insulator, so when it behaves as conductor. So it behaves as insulator at temperature 0 Kelvin. So while we maintain the temperature of 0 Kelvin, it behaves as insulator. So when it behaves as a conductor, so adding impurities or otherwise increasing temperature, so the valence band electrons or atoms will absorb the energy and goes to higher energy level. So higher energy level will be the conduction band. Okay. So with the valence band electrons will absorb the energy and goes to higher energy level. So at that time it will contribute current. So it becomes as a conducting material, right? Okay. So this is the semiconductor. So we know about the types of semiconductor, right? So what are the types of semiconductor? Intrinsic. So based on purity, we have two types of semiconductor: intrinsic semiconductor and the extrinsic. So what is meant by intrinsic semiconductor? So without impurities. Okay, purest form of semiconductor is simply called as intrinsic. So give me any example for intrinsic semiconductor. So silicon and germanium. So these are only purest form of semiconductor, right? So then what is meant by extrinsic semiconductor? Adding impurities. So based on impurity, so we have two types of extrinsic semiconductor, right? So p-type semiconductor and n-type semiconductor. So these are all the types of semiconductor, right? So based on purity, we have two types: intrinsic and extrinsic. So based on combustion, we have two types of semiconductor, right? So what are the two types? Elemental and compound semiconductor. So elemental is nothing but, so it consists of only one element. So compound means the mixture of elements. Okay. So in here we know about elemental semiconductor, right? So while during recombination, what is the recombination? Recombination of electrons and holes. Okay. So while during the recombination of electrons and holes, so the elemental semiconductor will emit heat, right? So that's why all the electronic components are made up of only semiconducting materials. Okay. So that's why all the electronic components will emit the heat energy. Okay. Because of all the elemental semiconductors while during recombination, so it will emit the heat. So compound semiconductor, so while during recombination it will emit the photons. Photons means light. Okay. So now our topic is, so how design thinking will apply in the next generation semiconducting products. Okay. So how design thinking will helps to create innovative and so efficient products, right? Okay. So efficient and user friendly products. Okay. So our discussion will be the, so how design thinking will be useful, so helping the next generation semiconducting materials. So from semiconductors from AI. Okay. So let's start.
Introduction. Design thinking for next generation semiconductors. Design thinking is a way to solve a problem by understanding the user needs. In the semiconductor industries, it helps to create better chips and electronic devices. Engineering use this method to design, think, and test and improve their quality. It helps to make products faster, smaller, and more efficient. This is used in many advanced technologies like Ideate, AI, and smart devices.
What design thinking in semiconductor? Traditionally, semiconductors are development focused on only performance like size, power, and light. But today's world demands more, better user work experience, energy efficiency, sustainability, and integration with IoT and AI. Design thinking helps bridge gap between complex hardware and real human needs. In nowadays, real example for semiconductors, smartphones. It will help to performance, battery life, and performance speed management. In the real world example, OLED displays use less power in
take design thinking project in semiconductor. For example, Empathize, identify user needs. For example, some people want better smartphones and better battery life. Define, clearly state the problem. How can we design semiconductor for the next generations? And ideate to generate ideas. Best AI-based chips and quantum computer chips. Next one is prototype to build the model for next generation prototypes. For example, design a low power processor using advanced transistors and test and evaluate to improve the speed and high quality of the project.
Advantages is that it is very easy to use and it gives better ideas, more ideas, it gives more ideas, and it saves batteries and it improves performance. Disadvantages is that the cost is very high, it takes more time and it is very hard to change. Therefore, it is good for users, but it needs more cost and the performance is very slow.
Very good.
Conclusion. Design thinking helps create the next generation semiconductor products on focusing on user needed innovation and effective problem solving. It enables the developing of advanced and energy efficient and reliable technologies. Energy efficiency unlimited its ensure semiconductors produce under practically and future ready.
Okay, very good. So in today's video, we discussed about how design thinking will use chemicals in the manufacturing of next generation devices, semiconductor devices, right?